Okay, let's just dive right into it, because June 2026 has been an absolutely wild ride. We are seeing massive financial moves, quantum leaps, and, maybe most incredibly, the groundbreaking base editing of human embryos all colliding in a single news cycle. So if you've been feeling like the future is suddenly accelerating, well, you aren't alone. The data we're looking at today proves it.
We have to start with the sheer scale of the money moving right now. Look at this number, $60 billion. That is SpaceX's unprecedented option to acquire the AI coding startup Cursor, with a $10 billion fallback for joint work. Now, for context, Cursor is a 2-year-old application. 2 years. The fact that a massive aerospace company is willing to deploy this kind of capital for a coding environment, that's our first massive signal that something has fundamentally shifted.
And right next to that, we have this one. Alphabet simultaneously sold off $80 billion in stock specifically to fund a massive AI spending spree. It brilliantly illustrates this wider land grab we're seeing. The big tech giants are literally liquidating their traditional assets to buy the future, and they are doing it right this second.
So, to make sense of all this future shock, here is our agenda for this explainer. 1. The multi-billion-dollar land grab. 2. The 2026 quantum leap. 3. Agent swarms and generative AI. 4. Robotics and biological breakthroughs. And 5. Regulation and the labor market.
Section 1. The multi-billion-dollar land grab.
Now, you might be wondering, why on earth is Cursor valued at $60 billion? Well, users on developer forums are pointing neutrally to Cursor's telemetry and user data, which trains their Composer 2 model. They hit the nail on the head. It's not just about the software. It's about 2 solid years of behavioral data from human coders. That data is the exact fuel needed to train the next generation of AI. In an industry where the software itself is relatively cheap to replicate, that data is a massive, highly defensible moat.
Section 2. The 2026 quantum leap.
But to understand why these companies are so desperate for all this data, we really have to look at the hardware engines powering it. Our classical infrastructure is literally reaching its limits. So, the crucial point here is the fundamental difference in architecture. Quantinuum uses this perfect analogy. Comparing classical to quantum is like comparing a flute to a drum. They both play music, sure, but through entirely different physics. Classical bits exist completely independently of one another, but quantum bits, or qubits, they can be entangled. The state of one directly influences its partner, no matter the distance. This allows quantum systems to accurately model highly complex chemical and physical systems that would be completely impossible for traditional computers. To actually make this a reality, companies are pushing some brilliant engineering solutions. For instance, they're using laser cooling that completely bypasses the need for scarce resources like helium-3. We're talking about cooling systems to 1,000 times colder than older superconducting approaches. They've also solved the infamous wiring problem by broadcasting signals to control qubits in bulk, and they've introduced junction technology for large-scale, grid-like scaling. What does all that mean? It means fault tolerance isn't just a pipe dream anymore. It is a near-term reality.
And we know it's a reality because there is real, massive federal backing here. IBM just won a $1 billion award for U.S. Foundry to help deliver a 200 logical qubit machine by 2029. They are committing over $10 billion in the next 5 years to achieve this quantum Starling system. We are rapidly transitioning from theoretical physics straight into industrial manufacturing.
Section 3. Agent swarms and generative AI.
With these crazy new computing frameworks evolving, the software running on top of them is totally changing how we create. The tools we use to interface with technology are being entirely rewritten. Industry leaders at the AI Engineering Code Summit are literally projecting that traditional developer environments will be dead by the end of 2026. Dead. Replaced entirely by these context engineering AI swarms. Instead of one single AI trying to understand a massive codebase, we're moving to multi-agent ant swarms that verify and correct each other to sidestep model limitations. It's a completely different paradigm for building software.
And you can literally see this scaling right now in the real world. Google DeepMind's AlphaEvolve is optimizing quantum TPU or AI chip designs, reducing quantum circuit errors 10-fold. Then you have Google Flow, which instantly reframes a video shot just by typing a single sentence. You don't have to reprompt the whole scene at all. You just tell the AI, hey, change that butterfly to a bee, or turn on the apartment lights to the beat of this song. Add in tools like Dubbing V2, which perfectly preserves a speaker's exact emotional tone and cadence across 90+ languages, and the barrier between imagination and execution, it's virtually disappeared.
Section 4. Robotics and biological breakthroughs.
Now lean in for this one, because this is an absolute game changer. We are moving past digital pixels and into manipulating physical matter and DNA. Base editing human embryos. Columbia scientists are now effectively erasing inherited diseases in human embryos before birth. They successfully edited fetal hemoglobin and LDL, the gene responsible for bad cholesterol, in human embryos. Let that sink in for a second. We aren't just treating diseases anymore. We are actively engineering them out of the human genome before a person is even born. And they're doing it using precise base editing that avoids the messy DNA breaks and chromosomal damage of older CRISPR tech. This fundamentally redefines the future of human healthcare.
And it's not just embryos either. Life sciences models like OpenAI's Rosalind are getting vastly more efficient at genomics, dropping token usage by 31% for analysis tasks. Over in diagnostics, machine learning at the Francis Crick Institute successfully predicted lung cancer up to 5 years in advance using a 14-protein plasma signature. And in neurotech, Meta's Brain2 version 2 is translating brain scans into coherent text without any invasive surgery. The biological constraints we've lived with for millennia are just rapidly dissolving. And over in robotics, it's like something out of a sci-fi movie. We are seeing AI algorithms actually design modular robots that can adapt to unstructured environments and heal themselves when damaged. Researchers at Northwestern University created legged metamachines using evolutionary algorithms. If these machines suffer catastrophic physical injury, they can physically reassemble themselves. The line between a machine and a biological organism is getting incredibly blurry, for sure.
Section 5. Regulation and the labor market.
Because society is, frankly, not built to absorb change at this velocity. With rapid advancements in everything from swarms to that wild base editing we talked about, we have to look at the very real societal friction occurring. Anthropic just published a really stark warning based on these two metrics here, suggesting we could be looking at a great recession for white-collar workers. The report shows that while AI theoretically has the capacity to handle a vast majority of computer science and administrative tasks right now, enterprise adoption is actually quite low. It's masking the reality. But that gap is going to close, and when it does, the impact on the labor market is going to be deeply disruptive. And this tension is actively playing out in the courts. The U.S. government has attempted to restrict access to advanced models over national security concerns, which led to an immediate legal battle. Following the banning of Anthropic's Fable 5 and Mythos 5 models, Anthropic sued the government, and they specifically won a federal injunction against the Trump administration to halt orders cutting ties with federal agencies. It's a crystal-clear illustration of the immense friction between private tech acceleration and the national security apparatus, with both sides trying to control the most powerful tools ever created. When you step back and look at the totality of what we've covered today, from self-healing robots to literally erasing diseases before birth through base editing, it gives you a bit of existential whiplash, doesn't it? Observers are really grappling with the sheer velocity of this change. Some internet commentators are noting that these breakthroughs make mortality feel almost like a question of timing rather than fate. As one observer starkly put it, they are already mourning those who didn't quite make it to this technological turning point.
So the crucial point to take away from this explainer is simply this. None of these things are happening in a vacuum. They are all fundamentally connected, and the future is arriving much, much faster than we ever anticipated. The capital, the computing power, the biological breakthroughs, and the massive societal shifts are all part of the exact same wave. The question isn't whether this convergence will happen, it's already here. The real question is, how are you preparing to navigate it as it reshapes literally everything we know? Thanks for joining me on this deep dive, and I'll leave you with that thought.